What does Elon Musk and Dom have in common? Is it their looks? Nah, Dom is obviously handsomer. Is it their fitness? Nah, Dom is obviously fitter. Is it their intelligence? Nah, Dom is obviously smarter. Then what do they have in common? It's their rockets! So what is up? Back in my hometown, and not gonna lie, all my stuff to make all the electronics is back in my dorm in college. So I'm gonna try to milk some of the stuff that I have here, which I haven't made a video about this one. I'm kind of surprised, which is my rocker. I haven't made a video about this, and I'm actually kind of surprised, which is my rocket glider, which is this right here. So today we're gonna dive into how I made this, look at a little bit about the physics behind it, and I hope y'all enjoy. Okay, so first we're gonna start in the back, because the back's always where the best things are. And the back has all the control fins. So if you look right here, the servo motor is implanted into the vertical stabilizer, so it reduces friction whenever the rocket glider is shooting upward. And just use the little 3D printed control servo horn to control it. Very basic. Very steep angles though, so whenever you program it with your controller, I didn't doesn't move that much. And then these two are the ailerons, so they act as the horizontal stabilizer and the ailerons. So they control the roll axis, and they also control the pitch axis, and just wire them up with with my controller, so they can act as both pitch control and roll control. So very basic. This is very basic Foamboard airplane design. So if you watch flight tests, they pretty much tell you all about it, and that's a little rundown of it. So we go from here. This is the good stuff right here. If you flip it over, so this is the rocket right here, and the rocket pushes right through the center of gravity, which is right here. So the center of gravity is somewhere around right. You can't even see it. Somewhere around right here. So you want the rocket to, imagine a straight line from where the nozzle is. You want the straight line to penetrate where the center of gravity is. So that is exactly how it's lined up right here. Has a small tilt, so it can hit that line, and so it can stay on course whenever the rocket is ignited. And then we have these two straws right here, which hold the tubes, as you saw in the video, so it can go straight, at least when taking off. And then if we take this out, so in order for it to fit in the tube, I 3D printed this little hole so it could fit in there and it won't burn the tube. But I mean, since it is a rocket motor, burns will happen over use and time. So you will have to replace some of these parts. But it's foam board and it's $1 and it's really cheap. I'm sure you could put something in the way to help reduce it, but like I said, this thing is literally on fire and it's hard to not make paper catch on fire. So now up in the front, got this little rubber band to hold down the main panel. You flip it open. Pretty much the receiver is in here and the battery's in here. And the battery holds the majority of the weight, so we can make the center of gravity kind of high up. Because just like any airplane, you want the center of gravity to be closer to the tip of the wing instead of being it closer to the back of the wing, or else you're gonna have stability issues. You always want the center of gravity to be a little bit forward from the center of lift. So that's how it is right here. Nothing really special in the front. We have a blunt nose so the air can go over it. But it's not really a triangle because it doesn't really matter that much. But if you look at the way the wing is designed, and you see how it's a triangle like this, so you want to keep the wing kind of compact and long, so all the friction that the drag that the aircraft feels is really minimized, because a glider is going to have long wings, which is going to take a lot of drag because there's a lot of surface area for the air to hit. But this right here, the surface area is very minimized because it's all right behind each other, so the drag is reduced. But since the surface area is the same, it still produces the same amount of lift, but it's just not as cushiony and efficient as a glider. So today was kind of a short video. Like I said, not in my dorm right now, visiting my hometown, so I don't have all my supplies here, but I do have an LED video coming up, so stay tuned for that. It's about how to control an LED strip with an Arduino, and also I'll be fooling with my Raspberry Pi a little bit because I brought that down here, and machine learning hopefully, and Python, so should be interesting in the future, so stay tuned for that. Thanks for watching.